Hello everyone, so let's go over resonance. So resonance is something that I see a lot of students struggle with, and the top two things that I'm noticing with students is one, students usually know what a carbocation is and what a carbanion is, but their issue lies in that when they're doing resonance, and for example they move a double bond, sometimes they can form a carbocation or they can form a carbanion or they could give oxygen a negative charge, but they're not writing the formal charges that they are creating. And so then whenever they don't write their positive charge or negative charge on their carbon or their oxygen, they lose points on their exam. And so that's issue one that I'm seeing. Issue two that I'm seeing with a lot of students is that particularly students that are beginning organic chemistry, it's not their fault. I mean, they're learning, but they forget to realize that whenever they're doing resonance, they forget that they already have hydrogens there. And what do I mean by that? So when you are in organic chemistry, most people do skeletal structures. And so for someone that's already been doing organic chemistry for a while, we already know, oh, that carbon has 2 hydrogens there or 1 hydrogen there or whatever. Even though you don't see it because we don't draw it in the skeletal structure, we know that the hydrogens are there. But sometimes when someone is beginning, they don't realize that the hydrogens are there. And so then when they move that double bond, they end up giving carbon 5 bonds. And that's wrong. Carbon can only have 4 bonds. So to show you my point, I'm going to show you what I see sometimes students are doing. And notice that this example that I'm about to do is completely wrong. I'm just doing it to show you why it's wrong. So I know some people are visual learners, so that's why I'm doing this. So if you have moved this pair of electrons here, sometimes what people will say, okay, carbon can have 5 bonds, I'm going to move this pair of electrons here. And that's wrong. Why? Because even though you don't see it, you have 3 hydrogens already there. This carbon that you see right here already has 4 bonds. And if you move this double bond here, you're giving carbon 5 bonds. So this is completely wrong. Completely. Like, it's just flat out wrong. The proper way to do resonance would be this. You move these electrons, and then these electrons go to the top. They go to the oxygen. And for some of you wondering, like, why does that happen? Why can that happen? Well, fluorine is the most electronegative element on the periodic table, and oxygen is very close to fluorine, so it is very electronegative. So it can hold a negative charge. So it is possible for oxygen to hold that negative charge. Likewise, for carbon, since carbon is more electropositive, carbon can also hold a positive charge, but I'm not saying it can only hold positive charges. No, carbon can also hold negative charges. And likewise, in resonance, you will see cases where oxygen has a positive charge. So in the following example, I'm going to show you when oxygen could have a positive charge in resonance. And notice it has to do with, again, if you're moving your double bonds, you could be creating positive and negative charges. I mean, because of the movement of electrons, what I'm trying to say. Let me rephrase that. When you move a double bond or an electron pair, your formal charge on that element can change. It can be positive, it can be negative, or it could be neutral. So going back to this, when I move this pair of electrons, I'm going to form a double bond, yes. And notice that the carbanion is now neutral. And then the double bond, the pair of electrons that goes to the oxygen, gives oxygen a negative formal charge. Again, if you don't know how to calculate formal charge, I have a separate video on that. But that's why you're going to see oxygen with a negative charge in this case. Okay, I know that was a lot. So if you want to pause the video and then come back to the next, do so. But now let's go on to the next structure. So in this example, I'm going to show you how you can do resonance, step by step by step. So in this first step, if I move this pair of electrons, one, I'm changing the formal charge of oxygen, which is why you see a positive on the next resonance structure. Because again, Now oxygen is going to have a positive formal charge. That's one thing to note. Second thing to note is that if I move this pair of electrons, I'm going to give carbon 5 bonds, and that can't happen, which is why this double bond has to move. And when that double bond moves, notice that I'm going to form a carbanion, because even though you don't see it, there's a hydrogen already there, which I'm showing in the next structure. Now, if that pair of electron moves, again, the next carbon being this carbon, is going to have 5 bonds, which is why this double bond has to move. Again, you form a carbanion because, again, that already had a hydrogen. So you form a carbanion, and then those pair of electrons move. And then this would have 5 bonds, so then this electron has to move. And then when you form another carbanion, and then that moves. And when that moves, this would have 5 bonds, so then these electrons go back to the oxygen. And again, you form the structure that you started with. So, let's recap. What did we talk about? 1, be mindful of what you're forming. When you do resonance, you can form a carbocation, you can form a carbanion, you can give oxygen a positive charge, you could give oxygen a negative charge by moving the electrons. 1. So be mindful of your charges and writing them down, because you will get points taken off if you don't write them down. 2, be mindful of your hydrogens. If you're not comfortable with skeletal, at the very beginning of learning organic chemistry, write your hydrogens, so that way you can see, can I move my pair of electrons there? If it's a methyl group, like I'm showing in this example, you're not going to move your electrons there, because you would be giving carbon 5 bonds, and that's not going to happen. Now, you could move a double bond to, for example, from here, you could move it here. Again, this would be able to accept it because, again, it is a carbocation, so it has a free spot for those electrons to be. So I hope you liked this video. If you're still confused on resonance, please let me know in the comments. Again, these videos take time to create, so please follow, like, share, and thanks again for watching.